Hello, everyone. In this video, we'll continue working with the probability problems. And here we work with the endowment and deferred insurance. The first example, a 15-year endowment insurance death benefit is 10 issued to an individual at age 45. The benefit is payable at the moment of death. Given that the force of mortality is 0.02 and the interest rate is 8%, Z is a present value random variable for this insurance. We want to calculate the probability that Z is less than 5. This is a continuous insurance, the PDF of Z. If T45 is less than or equals 15, then Z equals to the death benefit 10, and then times the present value factor. Delta is the lateral law of 1 plus I. And then if the individual survives beyond the 15-year period, a survival benefit of 10 is payable at time 15. The value for Z is 10 times e to the power minus delta and then times 15. This is for T45 is greater than 15. We need to get the probability that Z is less than 5. In terms of T45, we get this probability statement and then simplify that. We get the probability that T45 is greater than 9.0065. And this is the diagram relating Z and T45. And Z is a monotonically decreasing function. All right, Z is less than 5. That is the upper portion of the graph. This corresponds to the event T45 is greater than 9.0065. In actuarial notation, we get the survival probability. We need to compute this quantity. We get 0.8352. All right, the next example, we swap to deferred insurance. A 5-year deferred whole life insurance, death benefit is 2, issued to an individual at age 50. Benefit is payable at the end of the year of death, and you're given TP50, 1 minus T squared over 225, and T is between 0 and 15. The value for new is 0.93. Calculate the probability that the present value random variable Z is less than 1. All right, so the expression for Z is 2, the death benefit, and then times nu to the power K50 plus 1, and then less than 1. Solving for that, we need to get the event K50 greater than 8.5513. So that is, we need to get the probability that K50 is greater than or equals to 9. Let's take a look at the diagram of the deferred whole life insurance. For deferred insurance, we also need to handle the probability within the deferral period. The probability that Z is less than 1, this corresponds to the event K50 is greater than or equals 9, and K50 is less than or equals 4. So that is, we need to add up the probability that K50 is less than or equals 4, and the probability that K50 is greater than or equals 9. K50 less than or equals 4 corresponds to 5Q50. And then the probability that K50 is greater than or equals 9, this corresponds to the actuarial notation 9P50. And we get TP50 equals to this expression. And therefore, we get the probability that Z is less than 1, which is 0.7511. Another example related to deferred insurance. A 4-year deferred whole life insurance death benefit is 10 issued to an individual at age 45. Death benefit is payable at the moment of death. The force of mortality is 0.02 and delta is 0.06. We need to compute the probability that Z is greater than 5. All right, we have the PDF of Z. The deferred period, 4 years. So if T45 is less than 4, there's no benefit, Z is 0. And then if T45 is greater than or equals 4, we get the expression for Z. We want the probability that Z is greater than 5. Solving for T45. We get 11.5525. Okay, the level Z equals 5. And then Z is greater than 5. That is the upper portion of the graph. This corresponds to the event that T45 is between 4 and 11.55. We need to handle the deferral period separately. Therefore, the probability that Z is greater than 5 is equivalent to getting the probability that T45 is between these two values. In terms of the actuarial notation, this is 4P45 minus 11.55 P45. Constant force of mortality, that is E to the power minus 0.02, and then times the value of T here, 4 and 11.55 respectively. Upon calculation, we get the answer 0.1294. All right, that's it for today's video. Thank you for watching and see you in the next video.